So here we have our periodic table. Okay, so yesterday in the notes, we kind of got to see that, I don't know, if you guys flipped it over at all in the back, you kind of notice something that happens right here, right? We see a 3P, then we go 4S and 3D and 4P, and it kind of looks a little confusing, all right? So if you had a chance to flip over your notes to see that, we're going to go over that right now, okay? So we'll come back to this in a second. Okay, so what I want you guys to do is with the first color, and again, make sure you're coloring lightly. We are going to be writing over these colors a little bit. But what I want you guys to do with that first color is we're going to highlight the first, or color in the first two columns. If you would like, you're also more than welcome to just outline them. Whichever one you would like. So what sublevel did I just highlight right now? The S sublevel. Great. Good job. So we're going to label that above. So hopefully if you have like a pen would probably be the best because you are, again, going to be writing over things, or a marker. If you need to borrow one, I have some up here, by the way. But, so we have S. How many orbitals are in the S sublevel? 1. Good. 1 orbital. How many electrons can it hold? 2. Okay. So what we're going to do to just kind of help us out is we're going to talk about, okay, if we go through that full orbital, what the number is going to be, right? And so for electron configuration, remember, it always has an energy level, a sublevel, and then how many electrons. All right, so we're going to talk about being at the maximum for any time that we're writing these out, okay? So we're going to have 1 S2. You're going to write 2 S2, 3 S2, 4 S2. Hopefully you get the idea. 5 S2, 6 S2, and 7 S2. All right? Now question, why did I leave a little gap right there? That's where we're going to put helium. So go ahead and throw helium right there. You can circle helium on the other side and show that you are throwing him right over there. Helium is part of that S sublevel, but it is a noble gas. He's kind of the exception to a lot of the rules, okay? All right, so I'll leave that up for a second. Okay, so the next part that we went over was the P sublevel, right? So P sublevel starts over at group 13. So I'm just going to shift my page over here. So you're going to color in or highlight around or whatever you're going to do your P sublevel. So this one I'll just color it in so that way there's a difference. Okay. Awesome. Good job. So we're going to go ahead and label this one P. So I'm just going to write it up here at the top. I do apologize. If I was a great teacher, I would have whited out all that before I copied it, and I totally forgot until I copied it, and I was like, oh, man. So we are going to be writing over a bunch of these words. All right. Sorry about that. All right. So P sublevel. How many orbitals are in our P sublevel? How many bunk beds were in the pink room? 3. Good. So 3 orbitals. How many maximum electrons can it hold? 6. So it can only go up to that number 6. Meaning if you see one that goes above that, like 3P7, that's incorrect. Okay? It can only go to 6. That's how much room was there. And you guys kind of got to see that in that picture. You have those little bubbles of space. They fit perfectly on 3 axes. When we're dealing with this one, we're going to have 5 axes, and this one we have 7. That's why the pictures got a little more complex as we move to the more elaborate sublevels. Okay? All right, so what we're going to write on this is we're going to also write the extreme over here. Okay? And we know that there is not a first floor or 1P sublevel. So we're going to start with 2. Exactly. So we're going to write this on the outside over here. So 2P6, 3P6. And I think you guys get the idea, so I'll stop talking. Just go ahead and write them in. All right. We also know that when we're trying to write in the number up here, right, and we're dealing with something like phosphorus in the middle, we don't write 3p6. We have to count across how many boxes we're going. So I'm going to write myself a little reminder of 1, 2, 3, 4, 5, 6, just so I know that that's what I'm doing whenever I'm trying to figure out how many electrons are in that sublevel. I have to count across. When we're doing the arrows, what is the number that you start doubling up your boxes? Which number do you start doubling up? At 4. Yeah, at 4, right? So I'm just going to draw a nice little line down right here so that I know this is where I start doubling up my boxes for orbital diagrams. Okay? That midpoint. Make sense? So this is just a little reminder sheet that you're kind of making for yourself. All right, so now let's deal with the ones that we didn't really have a lot of notes over, okay? And that is your transition metals right here in the center. That's going to be your D sublevel, and these bottom 2 rows are going to be your F sublevel. So what I want you guys to do real quick, just to prepare us for this, is you need to write LU and LR right here, because if you compare this to your blue periodic table that you guys all have, LU and LR are not there. It just depends which periodic table somebody prints out. Again, if Miss Fogel was amazing, she would have thought of that ahead of time too. So cross these guys out once you write down their little symbols right there, okay? And all that this means is that this whole thing fits in right in front of this, okay? Right in front of this. So don't worry about that little zigzag line right there, okay? So these 2 rows go right there. And then LU and LR start the D sublevel after it, okay? Just so you know. All right, fun stuff. So now that we've fixed our periodic table, now we can go back to talking about the D sublevel. So let's go ahead and label it. We're going to put a big D for this D sublevel right there, okay? How many orbitals does the D sublevel have? You might remember that number. It's on your notes if you forgot it. Well, there's 10 electrons. So we can count across. We have 10 electrons going across, but we have 5 orbitals. So go ahead and write 5 orbitals, but put 10 electrons maximum. Okay? So we're just informing ourselves about our maximum numbers. I meant to change colors. My bad. I'll change colors now. All right. So this is the little complicated part about the D sublevel. And that is that when we reach this D sublevel, when we start putting our electrons and they're filling up this D sublevel, that sublevel actually fits within the 4th sublevel. It's inside of it. Just like all the rest of these 3, 2, 1 sublevels, those are within the 4th, right? So just think of the Bohr model. Every time we added an energy level, it was a new ring. It was a new ring, new ring. So what we do here with these elements right in the middle is they fall back 1 energy level. So I want you to write N minus 1 right here. Okay? And then if you want this reminder at the top, N is equal to energy level. It's kind of a notation that chemists use when we're talking about energy levels. It's N, okay? Just like that ZEF thing that you guys saw, effective nuclear charge. The Z is your nuclear charge or the number of protons, all right? So same thing, N is your energy levels, all right? Okay, so we always go back 1. So if you look at where D sublevel starts, it's on row what? 4. You guys see that? So what is this going to be? 3. So what you guys can write is you can write 3D. I'm not going to put the little 10 because then it'll get really busy on my page. And you guys can already not see what I'm going to be writing because I'm writing over orange. But I'm going to put 3D. I'm going to put 4D. I'm going to put 5D. If you want to move it over and write it over your elements, that's up to you. Whatever will make most sense to you. Okay? Just know that you jump back in energy level when you reach these elements in the transition metals. And that's how the D sublevel works. F is even worse. So when you guys ready for F? Oh, actually, before we move on from D, we're going to count this over. 1, 2, 3, 4, 5. All right, so the other complicated thing that happens in the D sublevel, I will never test you over this, but just kind of highlight your 5th and then your 10th column. I'll show you what I mean when we start going over orbital diagrams, and I'll show you how this works, because we're going to draw an orbital diagram for chromium today, okay, in our notes. And basically what happens is this is your midpoint, this is your full point, right? 5 and then 10. When you are getting close to the midpoint or the full point, it means you have an electron in every single orbital, right? That number 5 and number 10, right? Number 10, you have 2 of them. Okay, so when you're getting close to that, like chromium, we're going to see in the notes today, he's going to steal one from the 4s sublevel. Isn't that crazy? Like, this is the way it works. It's just, hey. And you can kind of use the word stability. It wants to have the 5 electrons in every single orbital, or the single electron in every single orbital, so it's a full shell. Just like noble gases have that full shell stability, okay? These things as well. So I will show it to you, but I will definitely never test you over it, okay? All right, we'll get to that in a little bit. All right, so we highlighted the midpoint. So the bottom 2 rows down here, the lanthanide and actinide series, these are known as our F sublevels. So go ahead and label that as an F. How many orbitals are in our F sublevel? So bunk bed. 7, yep. 7 orbitals, 14 electrons max. That's why we had to erase those guys and get them out of there, because it was 15 down there. Okay? All right. So, with the F sublevel, this one gets a little complicated as well. So this one was n minus 1. F is going to be n minus 2. Yay. All right, so if we look at where these start, what period do these start on? The 6. So if it's n minus 2, what is lanthanide or lanthanum going to be? 4. Exactly. So it's going to be 4F. Actinium. There you go. I've only ever called them actinide and lanthanide. So that one is going to be 5F. So these guys fit in even further. They jump back 2 energy levels. That's what that means. They're really close to the nucleus, okay? Or closer than the rest of those rows. All right, so that's kind of what we're going to put for this. So if you want, you can highlight these 2 series in the original color, or just put a box around them, kind of like what I did with my first color. And that way you see your distinct sublevels on your periodic table. So this, I recommend if you put it into your journal, that way you have it to kind of refer to. You can still use your blue periodic table, but this will at least tell you what part you're looking at, which sublevel you're on, until you have it memorized, right? So I do have some glue, I have some tape, I have staples over there if you want to take a minute to do that. But we're going to look at your notes page and just right now after that, okay? So I'll give you guys 1 minute to kind of get yourself settled for that.